Picture this. You wake up one morning and you can't talk. Not because you're sick. Not because you're tired. Because talking hasn't been invented yet. Nobody around you has ever said a word. Ever. In the entire history of the planet, not one single sentence has ever been spoken. No, good morning. No, pass the mammoth meat. No, who ate the last berries. Nothing. Just grunts, gestures, and the occasional very awkward silence around the campfire. Now, here's the part that should genuinely mess with your head. That version of Earth isn't some fantasy. That was reality for millions of years. Our ancestors walked upright, made tools, raised children, hunted animals twice their size, and did all of it without saying a single word to each other. And then, at some point, somehow, someone opened their mouth and changed the entire trajectory of life on this planet forever. So today we're going to answer a question that sounds simple but has quietly driven scientists half insane for over a century. How did humans learn to speak? And fair warning, by the end of this video, you're going to look at your own throat completely differently. Stick around because the answer involves broken jawbones, a gene stolen from a mouse, gossiping cavemen, and a French linguistic society that got so sick of people's wild theories that they banned the topic entirely. Yes, banned. We'll get there. Let's start with the obvious question. Why don't we just know the answer already? I mean, we know when the wheel was invented. We know roughly when fire was tamed. Why is talking such a mystery? Here's the problem. Speech doesn't fossilize. When your ancestor grunted the very first proto-word 50,000, 100,000, maybe 200,000 years ago, that sound didn't leave a footprint. It didn't get preserved in ice. It didn't turn into a rock. It just vanished into the air the second it was spoken, and it never came back. So unlike tools or bones or cave paintings, language left absolutely nothing physical behind. Scientists are basically trying to solve a crime where the weapon evaporated the moment it was used. That's why, for a long time, actual serious scientists avoided this question entirely. In 1866, the Linguistics Society of Paris got so tired of people submitting wild, unprovable theories about the origin of language that they straight up banned any papers on the subject. Just banned it. Imagine being a passionate nerd with a theory about early human speech, and your entire academic society tells you, essentially, stop. We don't want to hear it anymore. That ban stuck around for decades. And honestly, it worked. Language origin research basically went quiet for almost 100 years. But here's the thing about scientists. Tell them not to think about something, and it becomes the only thing they think about. So slowly, quietly, through anthropology, biology, genetics, and even studying how babies babble today, researchers started sneaking back into the topic through side doors. And what they eventually pieced together is honestly one of the wildest stories in all of human evolution. So let's go back. Way back. Before words, before language, before anything resembling a sentence. Let's go back to the throat. Yes, the throat. Because before humans could ever say a word, we needed the actual hardware to do it. And it turns out, for millions of years, we simply didn't have it. Here's something that sounds almost too weird to be true. Chimpanzees, our closest living relatives, share about 98% of our DNA. They're smart, they use tools, they form friendships, hold grudges, and yes, they even seem to grieve. But even the smartest chimpanzee on Earth, even one raised from birth alongside humans and taught sign language, has never been able to physically say a single spoken word. Not mama, not hello, nothing. And it's not because they're not smart enough, it's because their throats are built completely wrong for speech. In humans, our voice box, the larynx, sits low in our throat. That drop creates a long, open space above it called the pharynx, and that space acts like a resonating chamber, letting us shape a huge range of distinct vowel and consonant sounds. Chimpanzees, and most other primates, have a larynx sitting high up, close to the mouth. Great for swallowing safely without choking. Terrible for making the acrobatic sounds required for speech. So somewhere in our evolutionary past, our ancestors' larynx started dropping. And here's the twist that should honestly worry you a little. That drop is dangerous. A lowered larynx means the pathways for breathing and swallowing overlap more, which is exactly why humans, unlike almost every other animal, can actually choke to death on food. Evolution basically gave us a trade. Risk choking on your dinner in exchange for the ability to eventually invent poetry, insults, and karaoke. Worth it? Debatable. But evolution made the call for us a long time ago. Now, when exactly did this happen? For years, scientists thought they had a neat trick to figure it out. There's a small, delicate horseshoe-shaped bone in your neck called the hyoid bone. It doesn't connect directly to any other bone in your skeleton. It just floats there, anchored by muscles and cartilage, and it plays a critical role in supporting the tongue and voice box during speech. Because it's shaped differently in humans compared to apes, scientists hoped that finding ancient hyoid bones would basically hand them a timestamp for when speech became possible. And in 1989, they got lucky. In a cave in Israel called Kabara, archaeologists uncovered a nearly perfectly preserved Neanderthal hyoid bone dated to around 60,000 years ago, and it looked shockingly similar to a modern human hyoid bone, nearly identical. For a while, this was treated like a smoking gun. Neanderthals, our chunky Ice Age cousins who we used to picture as grunting brutes in movies, might have actually had the physical equipment to talk, but hold on, because this is where it gets messier and honestly more interesting. Having the right bone doesn't automatically mean you can use it the right way. It's like finding a piano in someone's house. That doesn't prove they can play Beethoven. The hyoid bone is only one piece of a much bigger, more complicated puzzle involving nerve control, breathing patterns, and brain wiring. So the debate didn't end there. If anything, it exploded into a whole new argument that's still going on today. Because here's the uncomfortable truth. The throat is only half the story. You could have the most perfectly engineered vocal tract in the animal kingdom, and it would mean absolutely nothing without the right brain behind it. So let's talk about the brain, because this is where things get genuinely fascinating. In the late 1800s, two doctors, Paul Broca and Carl Wernicke, were studying patients with brain damage, and noticed something remarkable. Damage to one specific region, now called Broca's area, left patients able to understand language perfectly, but they could barely produce fluent speech. Their words came out slow, broken, effortful. Meanwhile, damage to a different region, Wernicke's area, produced the opposite nightmare. Patients could speak fluently, smoothly, with normal rhythm and grammar, but the actual content made zero sense. Word salad. Confident, flowing, completely meaningless word salad. This told scientists something huge. Language isn't just one skill sitting in one spot in your brain, it's a network. Multiple regions working together, each handling a different piece of the puzzle, like a factory assembly line where every station has to do its job correctly, or the final product falls apart. And this is where a certain gene enters the story, and honestly, it might be the single most famous gene most people have never heard of. It's called FOXP2. In the 1990s, researchers studying a British family, known in scientific papers simply as the KE family, discovered something remarkable. Roughly half the family members across 3 generations had severe difficulty with speech and language, struggling to coordinate the fine muscle movements needed for clear speech, and also showing broader language and grammar difficulties. When scientists dug into their genetics, they found a mutation in a single gene, FOXP2. Naturally, the media exploded with headlines. The gene for language, found, case closed. Except, as usual, real biology is far messier and far more interesting than a headline can capture. FOXP2 isn't some magic language switch. It's actually found in lots of animals, including mice, birds, and yes, chimpanzees. What seems to matter is a couple of tiny mutations that happen specifically in the human version of this gene. Mutations that appear to have become widespread in our species sometime within roughly the last several 100,000 years. Scientists have even done experiments where they inserted the human version of FOXP2 into mice. And no, before you get your hopes up, the mice did not start reciting Shakespeare. But their vocalizations did change, and interestingly, their brain circuitry involved in learning motor sequences also shifted, which lines up with the idea that FOXP2 might help fine-tune the brain's ability to control the incredibly complex rapid-fire muscle movements speech actually requires. Speaking involves coordinating around 100 different muscles in your lips, tongue, jaw, throat, and lungs, often multiple times per second. It's honestly one of the most physically complicated things the human body does, and most of us do it without even thinking. So somewhere along our evolutionary timeline, changes to genes like FOXP2, alongside changes to brain structure, alongside that dropped larynx we talked about earlier, all had to line up. Not one lucky mutation, a whole cascade of changes, probably spread across enormous stretches of time. But now here's a question that might be bugging you already. Even if the hardware exists, the throat, the brain wiring, the genetics, why would evolution even bother? Why would speaking give an early human enough of an advantage to actually spread through an entire species? This is where things shift from biology into something a little more, well, dramatic. One of the most compelling theories comes from a British anthropologist named Robin Dunbar, and it's usually called the gossip hypothesis. And I promise it's exactly as entertaining as it sounds. Dunbar noticed something interesting when studying primates. Most primates maintain their social bonds through physical grooming, picking through fur, removing bugs, sitting together. It feels nice. It releases bonding chemicals in the brain, and it keeps the group cohesive. The problem is, grooming only works one-on-one. You can't groom 5 friends simultaneously. And as early human groups grew larger, physical grooming alone simply couldn't keep up with everyone who needed social maintenance. There just weren't enough hours in the day to individually groom every single member of a growing tribe. Dunbar's theory suggests language may have evolved essentially as a replacement. Vocal grooming. Instead of physically touching one person at a time, you could talk to and be heard by multiple people simultaneously. And what do people talk about even today more than almost anything else? Other people. Who did what? Who can be trusted? Who's reliable? Who's a cheater? Who's dating who? Who stole whose berries? Gossip, in other words, wasn't some silly side effect of language. Under this theory, it might have been one of the very engines that drove language into existence in the first place, because knowing who to trust and who to avoid was quite literally a matter of survival. Kind of humbling, honestly. All those group chats you've been in, filled with drama and speculation about coworkers, might be running on the exact same ancient social software our ancestors used to survive on the savannah. Somewhere out there, a Stone Age human is looking down at us, nodding approvingly, thinking finally, someone gets it. But gossip isn't the only theory in the ring. There's also the idea that language evolved first through gesture, not sound. Watch a toddler before they can talk, and notice how much they point, reach, and wave their hands to communicate exactly what they want. Some researchers believe early hominids may have started with a rich system of hand gestures and facial expressions long before vocal language took over, and that spoken words gradually layered on top of and eventually overtook that gestural foundation. Interestingly, when humans speak, the same general brain regions involved in language also activate when we make hand gestures, almost like language and gesture share deep evolutionary roots, wired together in the brain, even today. Next time you watch someone talk passionately with their hands flying everywhere, just know there might be a few million years of evolutionary history behind that motion. Then there's another theory focused on tool making. Making stone tools, especially the more advanced kinds, required precise sequences of actions performed in a specific order. Hit here at this angle, with this much force, then rotate, then strike again. Some researchers argue that the brain regions used for planning and sequencing complex tool-making actions overlap, significantly with brain regions used for constructing grammar, sequencing words into structured, meaningful order. In other words, maybe the same cognitive upgrade that let our ancestors build better spears also happened to let them build better sentences. So which theory is correct? Gossip, gesture, tool making, something else entirely? Honestly, most researchers today think the real answer probably isn't a single clean story. It's likely a messy, overlapping combination of all these pressures pushing in the same general direction across an enormous span of time, each one reinforcing the others. Now let's talk timeline, because this is genuinely one of the most hotly contested corners of the entire field. Some researchers argue that basic vocal communication, simple sounds, calls, warning signals, may stretch back over 1 million years, possibly even connected to early members of the genus Homo like Homo erectus, who show evidence of controlled fire use, cooperative hunting, and long-distance migration out of Africa. Behaviors that arguably benefit heavily from some form of shared communication, even if it wasn't full-blown language as we understand it today. Other researchers argue that full, modern, grammatically complex language, the kind capable of expressing abstract ideas, hypothetical situations, and complex storytelling, might be a far more recent development, potentially emerging alongside anatomically modern Homo sapiens sometime within the last 200,000 years, possibly even accelerating rapidly somewhere between 50 and 100,000 years ago. And that second window lines up suspiciously well with something else major happening in the archaeological record. Around that time, we start seeing a genuine explosion of symbolic behavior. Elaborate burial rituals, complete with grave goods carefully placed alongside the dead. Pierced shell beads clearly used for personal decoration. Ochre pigments, likely used for body art or symbolic marking. Later, stunningly detailed cave paintings depicting animals with remarkable anatomical accuracy. This period is sometimes nicknamed the Great Leap Forward, or the Cognitive Revolution, and a lot of researchers suspect that fully developed language might be the underlying spark behind this sudden explosion of symbolic, abstract thinking. Because think about what full language actually allows you to do. It's not just about naming objects in front of you, it lets you describe things that aren't physically present. It lets you plan for a future event that hasn't happened yet. It lets you warn someone about a danger they've never personally encountered. It lets you pass down accumulated knowledge from one generation to the next with incredible precision, instead of every single person having to rediscover survival lessons completely from scratch through painful trial and error. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. Once that capability exists, cultural knowledge can build on itself, generation after generation, in a way that raw biological evolution simply cannot match in speed. And that, right there, might be the single biggest reason Homo sapiens ended up dominating this planet while other incredibly capable, intelligent hominin species, Neanderthals, Denisovans, and others, eventually vanished. It likely wasn't a simple case of us being smarter individually. Emerging evidence increasingly suggests Neanderthals were remarkably sophisticated, capable of symbolic thought, controlled fire use, and complex tool-making. The real difference might have been in how efficiently knowledge could spread and accumulate across an entire population. A tribe that can share detailed, abstract information, share complex plans, coordinate large-scale strategies, and pass refined knowledge down through generations holds an enormous compounding advantage over a group limited to simpler forms of communication, even if the raw brain power on both sides is roughly comparable. Language, in that sense, might be one of the most powerful technologies humans have ever developed, arguably more transformative in the long run than fire, or the wheel, or even agriculture, because language is the very tool that allowed all of those other innovations to be explained, refined, and passed along efficiently to begin with. Every single piece of technology you're currently using to watch this video exists because thousands of years of accumulated language-based knowledge transfer eventually led to it. Now, before you assume this is all locked away in the distant, dusty past, here's something that might genuinely surprise you. We can actually watch a strikingly similar process happen in real time, within a single human lifetime today. In the 1970s and 80s in Nicaragua, before organized schools for deaf children existed in the country, deaf children largely grew up isolated from each other, each relying on their own family's improvised home gestures to communicate. When the country finally opened its first schools for deaf children, these kids were brought together in significant numbers for the very first time. Individually, none of them arrived with anything resembling a fully formed language. But almost immediately, something remarkable started happening. The children began developing a shared system of signs on their own, spontaneously, without adult intervention. Even more strikingly, the youngest children who arrived later actually took the emerging communication system and rapidly transformed it, adding consistent grammar, structure, and complexity that the very first generation hadn't fully developed. Within roughly one generation, an entirely new, fully functional sign language, now known as Nicaraguan Sign Language, essentially built itself from scratch. Let that sink in for a moment. Children, largely on their own, without a designed system handed to them by adults, effectively recreated the emergence of language in real time within living memory, right in front of researchers who were able to document the entire process as it unfolded. It's about as close as science has ever gotten to directly observing language invent itself. Before we wrap up, there's one more piece of evidence worth throwing into the mix, and it comes from a place you'd least expect it. Babies. Every single human baby on Earth, regardless of culture, regardless of which language surrounds them, goes through nearly identical stages of learning to speak. Around 6 to 8 months old, babies everywhere start babbling in the same basic repeated syllable patterns. Ba ba ba, da da da, completely independent of whether their household speaks English, Mandarin, Swahili, or anything else. Deaf babies exposed to sign language from birth even babble with their hands, on a strikingly similar timeline. That's a pretty strong clue that something about language acquisition is deeply hardwired into our biology, not something we're purely absorbing from scratch like a blank slate. Even more remarkable, young children can absorb the wildly complex grammar of their native language with almost no formal instruction by roughly age 4 or 5, without anyone ever sitting them down and explaining what a subjunctive clause is. Meanwhile, adults trying to learn a new language later in life often struggle for years with grammar rules that a toddler picks up practically by accident, just from being surrounded by conversation. Some linguists believe this points to a kind of biological window, a period where the brain is exceptionally primed to absorb language, and that window may be a living echo of whatever evolutionary pressure originally pushed our species toward speech in the first place. And here's a genuinely mind-bending example. There are certain human languages today that still use click consonants as actual meaningful sounds within words, most famously several languages spoken by groups in southern Africa. For a long time, some researchers speculated these click languages might represent an unusually ancient linguistic lineage, possibly hinting at features closer to how the very earliest human speech might have sounded. That particular idea remains debated and far from settled, but it's a great reminder that the incredible diversity of roughly 7,000 languages spoken across the world today isn't just cultural decoration. It's a living fossil record of sorts, still branching, still evolving, still being reshaped with every single generation that's born. So where does all of this leave us? Honestly, still without one single, perfectly clean, universally agreed upon answer. And if that feels a little unsatisfying, that's completely fair. But maybe that's also exactly the right way to end this, because the true story of how humans learned to speak wasn't some single dramatic lightning bolt moment. It wasn't one caveman suddenly blurting out the very first word while everyone around him gasped in amazement. It was an unbelievably long, slow, layered process, unfolding. Over hundreds of thousands, maybe over 1,000,000 years. Our throats gradually reshaped themselves. Our brains gradually rewired themselves. Our genes gradually shifted, letter by letter, generation after generation. Our social lives grew more complex, demanding better tools for tracking who could be trusted. Our hands gestured long before our voices ever fully joined in. And slowly, unbelievably slowly, all of those separate threads eventually braided together into the single ability that now lets you understand every single word in this sentence. Effortlessly, instantly, without even having to think about it. Every conversation you've ever had, every argument, every joke, every bedtime story, every single word of every song you love, all of it exists because of an evolutionary journey that took hundreds of thousands of years and that we're still only partially piecing together today. And here's the strange part. We still don't have a time machine. We can't travel back and press record the first time a human ever tried to say something meaningful to another human. Every theory we've walked through today, the dropped larynx, the FOXP2 mutations, the gossiping tribes, the gesturing hands, the tool-making brains, all of it comes from piecing together scraps of evidence left behind by people who had no idea they were being studied by their distant, curious descendants tens of thousands of years later. In a weird way, that's kind of beautiful. The people who first learned to speak weren't trying to leave us a legacy. They were just trying to survive, trying to warn a friend, trying to ask for help, trying to keep their kids close during a cold night. And somehow, out of all that ordinary, desperate, everyday effort, the entire foundation of human civilization quietly took shape. And somehow, all of that chaos comes together so smoothly that you never even have to think about it. You just open your mouth and the words come out.